Hello, thank you for watching this video. So in this video, I'll be doing question 2 of May, June 2024 question paper, mathematics paper 2. And the topic is statistics, or maybe one would like to call it cumulative frequencies. So I'm going to read question 2 statement and then try to answer the questions that follow. So let's go. They are saying 50 athletes need access to suitable training facilities. The table below shows the distances in kilometers that they need to travel to obtain access to suitable training facilities. So you are given a group of 50 athletes, right? And they need to access these suitable training facilities. So if you're an athlete, your fitness level need to be at top levels all the time, or peak conditions if you might. So in order to do that, you need to have good training facilities, modern training facilities, so that you can keep up with the standards of other athletes that you are competing with, maybe on a professional level or maybe not so professional level. So these athletes who are given distances that they need to travel, at least, to access those suitable training facilities. For example, if you look at these three athletes, because you can see here we have distances in kilometers, and you have number of athletes. So these three number of athletes have to travel from a minimum of 0 kilometers but less than 5 kilometers to access a suitable training facility. Then these 7 athletes here, you have 7 athletes here. These 7 athletes have to travel a minimum of 5 kilometers but less than 10 kilometers to access a suitable training facilities. Then we have 20 guys here, 20 athletes. So these 20 guys, they have to travel at least 10 kilometers but less than 15 kilometers to access the training facilities. This goes on until the last column, until the last row here. On the last row, you have 3 athletes, right? These 3 athletes have to travel a minimum, at least 25 kilometers to access a training facility, but less than 30 kilometers. That's what you are told here, right? No problem. So, this number of athletes that you are given here, it is these 3 people that you can see here, or each number that you can see here. It tells you the number of people that fall on a certain interval, right? It doesn't mean these 3 people all have to travel the same distance, but the distance that they all travel falls within that interval. So these are the grouped numbers based on the distance based on the distances, or based on these intervals. So, which is this grouped number that you see here is called the frequency, right? So, which means how frequent do you find athletes that have to travel from 0 to less than 5 kilometers out of that 50? Only 3 of them, right? So on the second one, which is you can find 7 athletes that will have to travel from 5 kilometers by less than 10 kilometers. So this is a frequency. All these numbers that you see here are frequencies. It doesn't mean each group of people, which means these 20 people, they all travel exactly the same distance, but the distances that they travel, most of them, they fall within this interval. This is what this means. Fine. So I'll go on to the next question now. To the first question, I think I've explained enough what these things mean. So at 2.1, they say, complete the cumulative frequency column provided in the table in the answer book. So they want us to complete a cumulative frequency column that is provided in the answer book. So I don't have an answer book. I have this question paper here that I was given by, that I requested, because I didn't have this question paper. I requested this question paper from one of the guys that do these question papers on YouTube as well. So I asked him. So I don't have the answer book that I need to complete the cumulative frequency column, right? So I think we have to do that ourselves, right? So what I'm going to do, I'm going to take this paper here and create another column here. Here is it. I'm creating this column. Here is it. Is it? So they're saying this is a cumulative frequency column, right? So I'm just going to write CF here for cumulative frequency. So because they want a cumulative frequency column. So I'm just going to write CF, which means cumulative frequency. This is what this means. Fine. Then now, the next question becomes, what is a cumulative frequency? A cumulative frequency is a total up to date, which is up from the beginning to now. What is the total? Right? From the beginning to now, what is the total? So, I'm saying a cumulative frequency is a frequency, is the total up to date. Right? I'll just explain with what I have here so that I don't dwell much on the other stuff and lose a lot of time. So, for example, say you have 3 number of athletes, right? So in simple terms, these 3 number of athletes, you can just say these are athletes that have to travel less than 5 kilometers. So if we're looking at this, we say at this very moment, we're looking at cumulative frequency, at this very moment, right? Well, how many people traveled a total less than 5 kilometers? You are looking at the total at this very moment. How many people traveled a total less than 5 kilometers to access a suitable training facilities? It's only these 3. Because these 3 people, you know that they traveled less than 3 kilometers to access these training facilities. So if I'm asking you how many people traveled less than 5 kilometers, it should only be these 3 people. So the cumulative frequency, which is the total up to less than 5 kilometers, is what? Is 3. Here is it. We have it. It's 3. I hope this 3 is visible. It doesn't look very nice. Fine. Then you are done with this cumulative frequency for the first row, right? No problem. We are going to the second row. So, what is your total for the second row? The total for the second row is this less than 10, right? So you want to know how many people travel less than 10 kilometers. Of course, these 7 people travel less than 10 kilometers. And then now the question becomes, are they the only people who travel less than 10 kilometers? No, they are not. These who travel less than 5 kilometers, these 3 people that travel less than 5 kilometers also travels less than 10 kilometers, because you know that 5 is less than 10. So even these 3 guys here, they also travel less than 10. So if you want the total up to date, you should add the number of all of those people who travel less than 10 kilometers. So these 3, they travel less than 10 kilometers, and these 7 travel less than 10 kilometers. So if you want the total up to date, it's a total of 3 plus 7. So you add these 2, and they give you what? They give you 10. So what you have at this very moment, the people who travel less than 10 kilometers is this 3 plus the 7. So it's 10 people. That's how this thing goes. So the cumulative frequency is the total up to this very moment. Right? No problem. I'll continue. We're going to the next one. So we want the total up to less than 15 kilometers. So we want the total of everyone who traveled less than 15 kilometers. So we know these 20 guys, they traveled less than 20 kilometers. Less than 50, sorry. We know that these 20 guys, they travel less than 20 kilometers. Now the question is, are they the only people who travel less than 20 kilometers? No, they are not. Because these people travel less than 20 kilometers because they travel less than 10. And these 3 people, they travel less than 20 kilometers because they only travel 5. So now, if you want people who travel less than 15 kilometers, you are looking for everyone who travel less than 15 kilometers. And that is this 20 people plus this 7 plus this 3, which is what? Which is 30. So you have 30 people that traveled less than 20 kilometers. 15 kilometers, sorry. So now what you also need to notice is that the cumulative frequency, as I said, right, it tells you the total up to date. So instead of adding this 3 and the 7 and the 20, you could have just taken this, because you know at the end of this less than 10, you only had 10 people that travel less than 10 kilometers. So you could have just added this to that and get to 30. Fine, let's continue. So the next row, you want the total number of people that traveled less than 20 kilometers at this very moment. So you know these people, they travel less than 20 kilometers, right? You know that they did. They travel less than 20 kilometers. Fine, no problem. The question is, are they the only one? No. Everyone before that, they all travel less than 20 kilometers, because you see, it's 15, it's 10, and less than 5. right? So how many are those people above that? You can add all this, or you can take this, because this is the total of all those people, because those are the people that travel less than 15, which include everyone above. So you can just say 30 plus 12, and that will give you 42. So what this tells you is that 42 people travel less than 20 kilometers. So it's a total up to that very moment. Let's continue. So same thing. You want the total of people who travel less than 20 kilometers. It's these guys here, because we know that they travel less than 20 kilometers because they're in this interval, right? And everyone above that. And everyone above that, they all travel less than 25 kilometers. How many are those people? You know, everyone above you add all these numbers, or you can just take them there and add 5. So it will bring you to 47 people. So yeah, 47 people. Right? No problem. So now we go to less than 30. So how many people travel less than 30 kilometers? All of them, they travel less than 30 kilometers. How many are they? There are 50. So 50 people, they travel less than 30 kilometers, because these 3 were only falling on this interval. Everyone else travel less than 30 kilometers to access a suitable training facilities. Or maybe if you want to follow the same logic that we've been using, you can say, okay, I have 3 here already and everyone above, and add all these numbers. And as you can see, we were told that there were 50, and we're getting this total here, which is the total number of all these people should be 50. So this number that you get here, it should be for everyone above. So it should always correspond to the number of items or the number of people that you are given. So this is a cumulative frequency for this data that you are given. No problem. So now, we're done with 2.1. So here's the cumulative frequency. It's 3, 10, 30, 42, 47, 50. So that is the cumulative frequency. So we've found the cumulative frequency. And then we go to the next question, which is 10.2, also 2.2. What are they saying at 2.2? They're saying on the grid provided. Okay, so now we're doing 2.2. 2.2 reads as follows. They're saying on the grid provided in the answer box, draw a cumulative frequency graph, Ogive, to represent the data above. So they want us to draw an Ogive graph using this cumulative frequency that we have here. That is what they want us to do. So to draw an Ogive function, right? So you need coordinates. That's what you need. You need the coordinates in order to draw the Ogive graph that you want. So let me write them here as well. So the first thing that you do, you plot, you see this 0 that you have here, right? Or this, or whatever number that you have here, you plot it against 0. So these are your x values, right? So this one, the first point, it should be this one, 0, and what? You plot it against 0. This one. If it was 19, it would be 19 and 0. This part here, this number that you see here. So, but now it's 0, so this 0 is this one, and you are going to plot it on against 0, which is your y is 0 as well. And then afterwards, go to the next one. So after that, you will mirror this and that. So you plot x is equal to 5, x is 5, and your y is 3. Then after that, you just go down this line. So it's going to be 10 and 10. No problem. So we have 10 and 10. Right? Then it's going to be 15 and 30. So you have 15 and you have 30 here. So these are the points that you are going to plot on your Ogive graph. Then you have 20 and 42. So you have 20 here. You have 42 here. You have 25 and 47, 25 and 47. You have 30 and 50. So you have going to plot 30 and 50. So these are the points that we are going to plot on our Ogive. So it's always this one with 0. Then it's going to be 5 and this, 10 and the cumulative frequency, 15 and the cumulative frequency, 20 and the cumulative frequency, 25 and the cumulative frequency, 30 and the cumulative frequency. So we're going to plot these points here. Fine. So let's go and try to plot that. I don't have what is it? I don't have a graph what is it? What do they call it? I don't have the grid, right? So I'll sort of have to create my own. So let's try that. I have this graph paper that I have here. So let's try to draw this ogive that they are talking about. So you can see you have 0. Oh, okay, this is the x, right? So you can see you have 0, 5, 10, 15, 20, 25, 30. So let's try that and say, okay, and let's say we have 0 here and say this is 5, 10, 15, 20, 25, 30, right? So we have 0, 5, 10, 15, 20, 25, 30. So you won't have to worry about this because they are going to give you the grade. So I'm just doing this because I don't have the grade. And then now if you're looking here, you're moving from 3 up to 50. So you can say maybe we have 5 here, 10, 15, 20, 25, 30, 35, 40, 45, and 50 here. So let's now join these lines, these dots of ours. Okay, this one not supposed to go underneath here, but it's fine. We'll try to be creative around it. So okay, it doesn't look very nice, but here we are. So okay, so this is 0, 5, 10, 15, 20, 25 here, 25, 30, there's no need for 35, so we can end here at 30. Do the same thing here on the vertical. So this is 5, this is 10, this is 15, this is 20, 25, 30, 35, 40, 45, and up here you have 50, right? No problem. So between 5 and 0, I have 1, 2, 3, 4, 5. So I have 5 lines, right? So I have 1. So I'm saying between 5 and 0, I have 1, 2, 3, 4. Oh, sorry. Between 5 and 0, I have 1, 2, 3, 4, 5. I have 5 lines, right? I have what? I have 5 lines between 5 and 0. So if you want to know the value of each line, so this is, I'll say this is the line value at the x-axis, right? This is the line value, which is each of these lines. I want to know what is the value of each of these lines. How do we do that? You'll say this one, the second one, which is 5, the second number 5, minus what? Minus the first number, which is 0, divided by the number of lines divided by 5. So you get that this answer is 1, which means each line represents 1 unit. Right? So which means if I count each line in between here, it should be 1. It should have the value of 1. Fine. Do the same thing on the y-axis. I'll say line value y-axis. On the y-axis, it's going to be second number, which is 5, minus the second number, or the first number, which is 0, divided by the number of lines. So I have 1, 2, 3, 4, 5. So I have 5 lines. So I'm not sure if you can see these lines because I'm struggling to see them, yet they're in front of me. So I hope you do see them. So I'll say, so it's going to be the second number minus the first number, which is 0, divided by the number of lines, divided by 5 lines. It's equal to 1. So which means each line have a value of 1. So the number that you see here, you are told that with the number that I've plotted here is the distance in kilometers. So I'll say distance, let me write with a black pen so this distance, x kilometers. That's the distance in kilometers. And up here, this is a cumulative frequency, which is the number of athletes, right? So I'll just say here, cumulative frequency, because it's what we're plotting, this guy here. It's the cumulative frequency. Okay, so what do we do? Now what you have to do, we just have to plot these points here, these points that we've seen. So said whatever number that is, it's going to be plotted with 0. So it's going to be, that number will be x and this y will be 0. So we'll have 0 and 0. So here is 0 and 0 here. Right? And then we say we have 5 and 3, which is 5 and 3. Here is 5. 3 is 3 lines above. So 1, 1, 2, 3. So here is 3 here. Here is 3 there. That's 5 and 3. Then we're going to have 10 and 10. Here is 10 here. Here is 10. And then go up to another 10. Here is 10 there. So it's this point over here. No problem. And then what? So we have 15 and 30, which is 15 and 30 there. So here's 15. You go and find 30. So here's 15. Go up the line to find 30. So here's 30 here. Right? The next one is 20 and 42. Here's 20. So go up to find 42. See, 20, go up, go up, go up. We're at 40. So the second line should be 42. So 40 here. So it's 41, 42. So here's 42 here. And then we go to 25. 25 goes with 47. 25 goes with 47. So here's 25. And then you move it up to 47. So this is 45. So this is 25, right? This is 25 line. And then 1 to 47, because we're at 45 now. 46, 47. The second line is 47. Is it? And then now we go to the last one, which is 30 and 50. So here's 30 and 50 is up here. Here's 50. Then to get your Ogive curve, you just join these things. So here's Ogive. I would expect it to look something like this. There's your Ogive. Looks like this. Let's write it down. Ogive graph. Here's it. Looks nice. Like it. So we're done drawing the Ogive graph. We'll go to the next one, which is 2.3. What are they saying at 2.3? Here's 2.3 here. Calculate the interquartile range of the data above. They want us to find the interquartile range of the data above. So how do we do this? So this is what we can do. I'll put this on the side here. So you want the interquartile range. So this is 2.3. You want the interquartile range. What is the interquartile range? Interquartile range, it is the difference between the largest quartile and the smallest quartile, right? So I'm saying the interquartile range is the difference between the smallest quartile and the largest quartile. So how many quartiles do we have? So you have we have three quartiles, right? So quartile 1, quartile 2, quartile 3, right? So let's say you have a data from here up until there. So this is the minimum value of your quartile. This is your maximum value of your quartile here. So if you want quartiles, what are quartiles? Maybe you're asking yourself, what is that in the first place? So quartiles, I would say in simple terms, just for you at least, I would say those are your positions where you can cut your data so that your data is splitted into equal parts. So if you want to split your data into 4 equal parts, you need to cut at 3 positions. You need to cut your data into 3 positions if you want to have 4 parts of your data. So the quartiles are the positions where you split your data so that you have your data in 4 equal parts. For example, quartile number 1 is the first quarter of your data. Let's say the first quarter is here of your data. The second quarter, which is where the half is here. And the third quarter is there. So this is the lower quartile, the first part, where, because you can see here is your data here. We have this part 1, 2, 3, 4. So these quartiles are the positions where you cut your data so that it is divided into 4 equal parts. Right? So at this point, you have quartile number 1, here you have quartile number 2, and here you have quartile number 3. So the first division must be made here. This is the first quarter of the data. Second division should be made here. This is the second quarter of the data. Third division should be made here. Here's the third quarter, and this is the fourth quarter. So the quartiles, they divide your data into 4 equal parts, as you can see here. So quartile number 1 is the first part where you cut to get the first quarter of the data. So you cut here. This is the first quarter of the data. Second quartile is where you cut. It's also the midpoint of your data. So you place another half so that you have what? So that you can have the second quarter. Third quartile, you put it there. Here's the third quarter, and there is the fourth quarter. So quartiles, they divide your graph into, so they divide your data into 4 equal parts. Right? No problem. So what do we do from here? So what do we do now? What do we do? So what we are asked to find, the interquartile range. How do you find the interquartile range? I said to find the interquartile range, the IQR, interquartile range, you say the maximum quartile, which is Q3 minus Q1. So in order to be able to find the interquartile range, I was trying to make this Q. In order to be able to find the interquartile range, you must know the third quartile and the first quartile, and then find the difference between those quartiles. So here, we don't have the data, right? A list of numbers, but we have, actually, we do have it. We do have it. So what we need to do, we need to use this Ogive graph of ours, this Ogive graph, to locate the first quartile, the third quartile. Then once we do that, once we locate the first quartile and the third quartile, we can find the difference between them. And the difference between those quartiles is the interquartile range, which is what we're looking for. Right? So let's try and find the interquartile range. Right? So to do that, let's find the quartiles first, the first quartile and the third quartile. So let's try to do that. How do you find the first quartile? I said the first quartile is the first quarter of your data. Right? To find the position of the first quartile, right? It's going to be a quarter of the number of items, right? Plus 1. It's going to be quarter of number of items plus 1. What is the number of items? The number of items, what is your items in this case are the athletes, right? So your N in this case will be the number of athletes. Your N will be the number of athletes. How many athletes did we have? We had 50 athletes. So which is your N is equal to 50, which is your N is equal to 50 because your 50 is the number of athletes. So to get the position of the first quartile, you must take it's a quarter of N plus 1, right? Which is where N is the number of athletes, which is 50. So to get the first quartile, it's going to be 1 over 4 into 50 plus 1, or 1 over 4 times 50 plus 1. What do we get that? We're going to get that is maybe let me punch it and see. Let's punch that 1 over 4 times 50 plus 1. This should be a 1 here. 1 over 4 times 50 plus 1 is 12.75. So you get that the position of the first quartile is at 12.75. Then what you need to do, these are the number of people, of course, but we don't have 0.75 per person. You need to estimate, go and find 12.75 here on the number of people, on the cumulative frequency, find it there, and then go trying to find the distance in kilometers. So let's do that. So what we're going to do, we're going to say, okay, now, we're looking for 12.75, right? We're looking for 12.75. So this is 10. This is 11, this is 12. 12.75 should be close to 8, maybe up here. So what we're going to do, we're going to join this 12.75. We're going to join this 12.75 to our Ogive graph or to our Ogive curve. Here is it over there. 12.75 joins there, and then you draw it down to this. Then you can read the number that you can get here. The number that I get here, I get 11. I get 11. I get 11. So what do I do? So which means, what does this mean? It means that my first quartile Q1 is at 11 kilometers. So I'll say my Q1 is equal to 11 kilometers. There is Q1, right? So if you want maybe Q2, you do the same thing. Do the same thing as this one. So position of Q2 is equal to 2 over 4, which is looking for the second quarter, into n plus 1, and then you can do the calculation same as this one and go locate it here and do the estimation. But I will not go and find Q number 2 because I don't need it. I only need Q3 and Q1. But what I'm going to do is what I did for Q1 and what I'm going to do for Q3. You can do it if you want Q2. So what do? We want the position of the third quartile. So what is this? The third quartile, right? So it's going to be 3 over 4 into n plus 1. And n is equal to 50 because we have 50 people. So it's going to be 3 over 4 times 50 plus 1. What is 3 over 4 times 50 plus 1? You can punch that in a calculator. 3 over 4 times 50 plus 1. And you get that is 38.25. Sitting at 38.25 people. But of course, you know that there's not a 25 people, whatever. But then now, you have that your third quartile is sitting at that position. Right? So let's go and find this position on the cumulative frequency. And then locate the distance. So we're looking for 38.25. So this is 35 here. So 36, 37, 38. So it should, here is 38 here. So it should just be above 38. It's a quarter of 30. A quarter after 38. So that's why your 38.25 is sitting more or less. Then you can join this. Sorry. You can join this to your Ogive, right? After joining to Ogive, you can pull it down here. Pull it down here. And this reads what? This is 15, so it's 16, 17, 18. So it reads 18. So which is your Q3 is equal to 18 kilometers. So therefore, Q3 is equal to 18 kilometers. So if you want the interquartile range, it's going to be Q1 minus Q3 minus Q1. So Q3 is equal to 18 minus Q1. What is your Q1? Your Q1 is equal to 11, right? Or to 11 kilometers. And what is 18 minus 11? Your 18 minus 11 is equal to about 7 kilometers. So your interquartile range is about 11 kilometers. So that's how to find this on an Ogive, in case you are given something like this before, or maybe you are interested. So I think I'm done with this one. So I'm going to go to 2.4. So this was 2.3. So let's go to 2.4. I'm going to take the graph. I'm going to take this paper. Then we do our 2.4. Okay, so now we're doing 2.4. 2.4 read as follow. They are saying the families of the 4 athletes above who stayed between 15 and 20 kilometers from suitable training facilities decide to move 10 kilometers closer to the facilities. In which interval will the number of athletes increase? Let me read this thing again. They are saying the families of the 4 athletes above who stayed between 15 and 20 kilometers from a suitable training facility decide to move 10 kilometers closer to the training facilities. In which interval will the number of athletes increase? Okay, so you can see for the interval, this interval that we are given here, this interval here is the interval between 15 and 20 kilometers. So at least 15 but less than 20, right? So they're saying 4 people who are staying on this interval are going to move 10 kilometers closer to the training facilities, right? So I'm going to write this interval down here again. So we had X, right? These people were staying at least 15 kilometers but less than 20 kilometers, right? How many were these people? These people, there were 20 of them. You can see them over, no, it's 12. There were 12 of them. So we have 12 people that were in this. We have 12 people that were in this class here, or that were in this interval. Then, what they're telling us, they're telling us that 4 of these people will move 10 kilometers closer. So you will have 4 that will move 10 kilometers closer to the training facilities. If these 12 people were all at least 15 kilometers from the training facilities, but less than 20 kilometers from the training facility, now 4 of them move, and 4 of them move 10 kilometers closer to the training facility, which means they are going to move out of this class. They're going to move out of this class to a class that is 10 kilometers less than this. So you had 12 people on this interval, right? And 4 of them are going to move 10 kilometers closer to the facility, right? They're going to move 10 kilometers closer to the facility. So the question you should ask yourself, which class is 10 kilometers closer to the facility than this one? If you look at this one is 5 kilometers closer to the facility than this one. And this one is 10 kilometers closer to the facility than this one, than this one. So what does this mean? It means if you are here and you move 10 kilometers away, so this will be minus 10, and what you will have there, you will have 5, at least, less than minus 10 again, you have 10 here. So, which means if you have 4 people that were on this interval and they move 10 kilometers closer to the training facilities, which means now they are less than 10 kilometers. They are less than 10 kilometers from the training facility, which means in that case they are falling on this interval at least. So, which is your 4 people, you will minus 4 people from this group and you will add them on that group over there. So this interval, which is the interval of at least 5 kilometers but less than 10 kilometers, will increase by 10 people because they will move out of this one, and this one, which had 12 people, will go down by 4 people and it will be like 8 people, and there you'll have about 11 people in that interval. So the interval that will have an increase in number of athletes will be this one, because 4 will move from this one and move 10 kilometers closer, right? Which is 10 kilometers less than the class that they were originally in. So in simple terms, the interval that will show an increase in number of athletes is this interval here, this one, which is for X values that are at least 5 but less than 10. Then we move on to 2.5. So now we are going to do 2.5. They are saying, calculate the estimate mean distance that the 50 athletes need to travel after 4 families have moved 10 kilometers closer to the facility. Clearly show all your calculations, right? So they want us to calculate the mean. No problem. What do you say? So what you know is, okay. So what do you say? You want to calculate your mean, right? So The distance here is from 0 but less than 5. To find the mean of this interval will be, okay, it's more like a representative distance. The average distance traveled by these people on this interval, you can say, is in the middle here, right? So you can say each person on this interval will travel a distance, an average distance of about 0 plus 5 over 2, which is about 2.5, right? And then average class distance. This is the average for the class. You're going to have to calculate the average class distance for all of these classes. And then now, from there, you take that average class distance as a representative distance traveled by everyone, or maybe by these 3 people there. So let's do that. So you can say 5 plus 10, which is 5 plus 10 over 2. The answer will be 15. 15 over 2 is about 7.5, right? Do the same thing here. You're going to say 10 plus 15, that's 25 all over 2, that's about 12.5. Are you with me? And I'll explain these later. Then you say 15 plus 20 all over 2. What is the answer? So it's about 17.5. So 20 plus 25. So 20 plus 25 divided by 2. What is the answer? This is 45. What is it? Yeah, it is 45. What is 45 divided by 2? That is 22.5. This is 22.5 that you have here. I was trying to say 22.5. Then what next? You say 25 plus 30. 25 plus 30 divided by 2. This is 25 plus 30 divided by 2. What is that you get? You'll get 27.5. That's where you are. So 25 plus 30, let me just double check, divided by 2. It is 27.5. I would think everything else is okay. So these answers that you get here. So this 2.5, what you are saying, the people on this class, which is these 3 people, they traveled this much distance. Each one of them traveled this distance. That's what you are saying, essentially. So these 11 people, each one traveled an average distance of 7.5, which was each one of them. You can say they traveled, because this is the average class distance, which is in each class, how much would you say each person traveled? So it will be the average of that class. So which means these 20 people, each one of them traveled about 12.5 kilometers. And these 8 people, each one of them traveled 17.5 kilometers. This 5 traveled about 22.5 kilometers. And these 3 traveled about 27.5 kilometers, each one of them. That is an average, more or less. So this is a class average, which is, if you look here, the average of each one, which is the midpoint of each of these class, will be your average distance. It's what you would like to think each person might have traveled. 5. Then you know that you have 50 people, and 3 of them traveled 2.5 kilometers, and 11 of them traveled 7.5 kilometers, and 20 of them traveled 12.5 kilometers. 8 traveled 17.5 kilometers, 5 traveled about 22.5 kilometers, and 3 traveled about 27.5 kilometers. So now, if you want the average of the entire data set, you must add all of these 3, 2.5s, and all of these 11, 7.5, and all of these 20, 12.5s, and so on, and divide it by the number of athletes, which is 50. Then you will get the average. So what is your average? Your average right, is equal to the sum of your data entries, sum of everything, divided by the number of entities. So which is your average is equal to, let's add these things. So you have 3 of these 3.5s, right? You have 3 of the 2.5s. So do we write all of them? You want to write 3 2.5s and 11 7.5s and 20 12.5s. No, that will be long. So what you can say, I have 3 of what? Of the 12.5s, of the 2.5s. With the first part, we're done with this. Plus what? I have 11 of what? Of the 7.5s. That's what you have. Plus, I have 20 of these. So 20 times this, which is, you have 20 of them. You don't have to add all 20 of them. It will take you forever to finish this. So I have 20 of the 12.5s. I have 8 of the what? Of the 17.5s. Plus, this is long. I'll write underneath here, but just think of it as just a continuous line. I have, so I'm done with this, So I have 5 of the 22.5s, which is these. I have 3 of the 27.5s, all divided by the number of entire people. So you know these people, you have 20, 11, what? It's all these athletes here. You have 50 of those athletes. So your average will be the answer to this. So just punch all of that in your calculator. So say 3 times 2.5 plus 11 times 7.5 plus 20 times 12.5 plus 8 times 17.5 plus 5 times 22.5 plus 3 times 27.5, all divided by 50. Right? You get that your answer is equal to 13.5 kilometers. So this is your average. So this is how I would have calculated the thing, and I hope it does make sense to you as it does to me. Thank you for watching. Cheers.